Hello. In today's presentation we're going to learn about data structures. This is intended for VCE computing students and in particular Unit 3 and 4 software development students. So the study design says that we're looking at characteristics of data structures including one-dimensional arrays, two-dimensional arrays and records with varying data types and a field index, also known as a primary key. Just for good measure, I am also throwing in associative arrays or dictionaries because I think you should know about these too, even though they're not specified in the study design. So, our learning intention is that students can describe the attributes of one-dimensional arrays, two-dimensional arrays, and database records. So, first of all, let's have a look at what a one-dimensional array is. It is a linear structure, which means that it kind of just goes in one direction like a line, and it stores multiple elements of the same data type in a consecutive memory location accessed through a single index. So let's unpack that. These boxes here start at 0, that's box 0. Then 1, then 2. Now actually this image has a fault in it. It should have 3. They should be consecutive. There should be no gaps whatsoever in there. So it's interesting that it missed that. So that's your index number there. Imagine that there is 3 there. So for instance, ages equals, and it's in square brackets in most languages to indicate that it's a one-dimensional array, 18, 22, 55 and 59, they're all integers. That first one will have the index of 0, 1, 2 and 3. So 4 items going from 0 to 3. They can be a fixed size or you can put items in and take items out. It's different in different languages. Sometimes you can put them on the end, sometimes you can put it at the start, you can remove them from the middle, you can swap them around. They're actually terribly versatile. They're kind of one of the bedrocks of programming. The elements are stored sequentially, so there will always be a number 3 despite what this picture says. And there is 0 index, so the first item is 0, and this still trips me up over all these years that the first one is 0 and the second one is 1. So that's what a one-dimensional array is. And it means you can reach in directly and say, hey, I want ages with an index of 3, and it will get me that item there. I don't have to get them all at once. I can pick one off the shelf. I can reach into just one box. So I've got my array here of ages. I'm then going to print ages 0, and I would ask you, what will that print? And that will print 18, and then I'm going to append 61, and so that array, if I were to look at the whole array again, would now read 22 in index 0, 55, 59 and 61. They don't have to be in order, by the way. They could be in any order. So how is a two-dimensional array different? Well, a two-dimensional array is a structured collection of elements arranged, they say, in a grid-like format. That's kind of how I see it described. I think of it as better understood as an array of arrays. So let's have a look at this to see what that looks like. So I say matrix here. So matrix equals, and I've got the square bracket there and the square bracket there. That's my first array. And there are 3 elements in it, and they're on their separate lines. And each element is in itself an array. So if we were to say this variable called element is going to be matrix, which is my two-dimensional array, and it's going to be index 1 and then index 2. Well, that's index 0, so that's index 1, within index 1, index 0, index 1, index 2. So what's that going to print? Well, it's going to print 6. So if you look over here, you'd be saying, well, the globe is in index 4, index 1. So it's a way of picking stuff out in 2 dimensions. I can't say I use this terribly often in my own programming. I tend to use a database when things were getting to this level of complexity, but it's certainly a data structure, and it's one that you're meant to know for the study design. So speaking of database records, they represent a single entry in a database table. So here on this first line, product number 1 is a laptop X1. It's in that category, it's got that price, and it's got that stock. Now you'll notice that we've got a variety of data types. In fact, we've got an integer over here, we've got a string, another string, a float, and then another integer. So we can and mostly will have a variety of data types. It contains information about one thing. So it normally has a kind of consistent meaning. This is a student, or this is a score, or this is a recipe, or this is an item. And it's composed of multiple fields. They are uniquely identifiable, and we call this thing here the field index or the primary index. And this is often auto-incrementing. So it'll be 1, 2, 3, 4. You won't ever reuse a number, but you can have gaps in the number. So if I were to delete item 3, it wouldn't reorder like a one-dimensional array does. The indexes are there in that field, and if you were to delete that field there, you would actually cease to have indexes. They're not auto-indexing. So you want to have one of these. I often call that ID in my own coding. I notice they've called it product ID there, and that shouldn't change. So this is just a closer look at that. I probably should have used that when I just talked through all of that. But all of these things are fields. All of these things are records, and that, of course, is the field index or the primary key. So you actually interact with this using queries. It might look like an Excel spreadsheet, but that's just a way of it showing it to humans in a way that we can read and understand. But in actual fact, you interact with it by giving it queries. Now these are SQL queries that I'm using here. SQL is not the only language, but this one here, for instance, will select, so it'll bring back all fields from the table called students. So going back here, that is the whole table. So it would bring back everything on every line. This one will bring back only the student name. So that would be the field name. So product name, category, price. One of these would be called student name. And it would bring it back where the age is 18. So it can actually look at all of the fields and say, when this one is doing what I want, then I'll bring back this one from this table. And you can do all sorts of tricky things such as ordering them. Now, what else can you do? Well, you can insert lines, you can delete lines, you can update them, and you can select the count, and there's a whole lot of things you can do within your queries. It's a language all of itself. SQL certainly is, and there are others, and they're yet another language that you have to learn, and that language lets you do quite sophisticated choosing and picking and altering of tables. This is the databases are very, very common in computing. Now, this isn't on study design, but I wanted to mention it anyway. This is an associative array. If you were here in person, I would ask you what another name for an associative array is. In Python, they particularly seem to like slightly different names for things. A one-dimensional array in Python is called a list, and an associative array is called a dictionary. So a dictionary stores key value pairs, and allows for non-integer keys. So instead of saying, hey, show me item number 1, it'll say, show me, I can't remember it. I think it's something to do with vehicles. We'll look at it on the next slides. This isn't in the study design. Don't worry about this if you're preparing for the exam. So I'm saying I've got an associative array of student bracket name equals John Smith. So if I say to it, what's student bracket name, it'll come back with John Smith. If I say student age, it'll come back with 19. If I say student course, it'll come back with computer science. So what you've got over here is the name of the array, and that's the key, and that's the value. And you often look it up by the key and say, hey, tell me what's the student, what the index of name equals. And there we go. So display student name. Again, really, really useful. I don't use them much, but they are very useful. So that's the end of this presentation. I hope you found it good.